not necessarily your laptop, but just one big box, right? Deploying all to one server somewhere, some Linux box, somewhere in the cloud. Now there's good and bad sides to this. The bad sides are probably the easier question. Maybe I'll ask you guys first. What's good about this solution? Sorry?
Easily done. Like
easily done. Very good. Yes. Cheap. Yep, it's definitely cheap. Get like a Linux box off DigitalOcean, Linode. You can run it from your bedroom. Frankly, it's simple. About the cheapest thing you can do. Any other ideas?
abstract.
Go on.
Actually, you don't actually have to like put anything together. Let's say.
Yeah, so it's simple is maybe what you're.
Yes.
Yeah, so it's just like it's one big box. All your shit in one big box. Easy. That's good. So kind of a corollary to that is that therefore you don't need to worry about secure communication in between your things. Like if I'm making unauthenticated calls to the back end, who cares? Unless I've done something daft like expose all the ports, only the front end can see that. Only things on the box can see that. So yeah, I mean, that's one concern that you just don't have, which is great. And simple and easy is kind of where you want to be for an MVP, because your needs are not the same as they are for a production application. It's about testing your idea quickly, making sure that it's got value, and steering it quickly as well, getting user feedback from actual users and making those changes and getting them out there. And the fact that it's simple and cheap, cheap is important because your MVP might go nowhere. You don't want to spend big on it and then find out that's it. So yeah, there's actually some kind of good things about this dead simple thing you can do. But there's also problems, and some of them will be major problems when it comes to production. Can anyone suggest what problems we're likely to get from just doing this? Scalability into this. Good. When you say scalability, you mean to requests, people, more users?
Yeah, when you've got to redesign the whole thing to actually be able to grow.
Yeah, and you don't want to have to redesign the whole thing. Any other things you guys could think of? If your bank was set up and that this was their infrastructure, how would you feel? What would worry you about that?
Not very safe.
The SQL is connected straight to the front end.
Yeah, so front end is a little bit of a misnomer here because it's, I'm assuming based on what you guys have done so far that it's going to be Next.js working with server-side rendering, which means that it's got browser side, but it's also got a server. So I'm not saying that like the browser is talking to the SQL database. Now you might say that there's defense in depth, and you might want your front end miles away from your database, but that's not really what I was going for here. It's maybe a more advanced concern. What you do want, though, regards to the database, is you want it to like work all the time. You don't want it to go down. When somebody really likes your MVP and they post it on Reddit and it goes on the front page and millions of people come in, you want it to scale with demand. You want the whole thing to scale with demand, and especially a database. When there's like a fire in your data center, you want it to switch over to another data center. So you're using EUS2, it's in London. Burns, you want it to switch over to Dublin so that there's continuity of service. And when the CTO gets a bit impatient and says, I'm just going to tweak this thing, and does it in production and crashes the whole damn thing, you want to be able to restore it from backups pretty quickly. None of which is easy for you if it's all on one box. Now you can set it all up. super tedious to do that. I don't know, has anybody ever like set up replication, geo-redundancy, that kind of thing on databases manually? No. Like you all look too alive to have ever done that. It's, yeah, it's tedious. So ideally, you want to pay someone else to do it. And best of all, you know, somebody that's doing a good job, you want a service that can do it for you. So the first thing I would do is take that out and put it into a service. So the obvious options are something like in AWS, we have RDS. In Azure, there is the same thing, basically, a SQL database as a service. And that's helpful because those, you know, Amazon and Microsoft are then looking after your database for you. You can just click a few boxes or configure a few options in your infrastructure as code to make sure that it's set up correctly. You don't actually have to get into the weeds of configuring the database yourself, which is much preferable. I mean, you pay them for the pleasure, right? But it's worth it because it saves you a lot of time and heartache. So that's that. The same applies to ChromaDB. Unfortunately, it gets a bit trickier with ChromaDB. So it's super for getting started and learning, which you guys have used it in your workshops already, right? Yeah. Downside of it is that it's too shiny and too new, and it's not provided on AWS or anyone else at the moment. That's on their roadmap. So we need to swap that piece out. If we're going for production concerns, we need to swap that out for another database, another vector database. Good news is there's loads of them. And they're all pretty interoperable. Well, not interoperable, that's the wrong word. They're basically the same concepts. And in fact, most of them are built on the same underlying technologies. A lot of them are just using face under the hood. So you can kind of expect the same kind of performance and properties. So those are some of the things that we know that we're going to need to worry about in the future. We don't need to worry about them when it's an MVP. So fine, the database goes down, cares? It's an MVP, you know. But we know we're going to worry about them in the future. So now we start in the back of our minds saying, right, is there a different choice we could make that suits our needs now, but which will still be good and won't cause us to rewrite everything when we go to production? Because I mean, one of the things about Chroma as well is that the API it's like a Python or JavaScript API, right? You use the client. So swapping that out, you need to prepare for that. You can't just swap it out straight away. If you've smeared the ChromaDB API all over your code base, and then later on you go, got to get rid of it, that's a big job unpicking that. So looking ahead, you can say, okay, at the very least, I need an adapter in front of this. I want to minimize where it's used. I want to make sure that I know when I do need to change it one day, this is how. So this is, yeah, kind of forward thinking. Okay. Yep. That's a little joke for anybody who's into Chinese mythology and Amazon data services. So, wow. Yeah, is it too niche for this crowd? Yeah, sorry. Couldn't resist it. So, oh, I've gone out too early as well. I was going to talk about this. It's all right. Look at the picture. So there, what we do, we could split it up, yeah. And I've gone a bit further here. SQL database is now an RDS. There is a little gotcha there as well in that you guys are working with SQLite, which is fantastic, but not on RDS. SQLite's kind of designed for embedded use cases. So like in apps on your phone, in fact, your phone probably has several SQL databases on it already. Your browser actually has an embedded SQLite database in it. You'll want to switch to something else longer term. Good option would be Postgres because it's short for PostgreSQL. it's quite standards compliant, well, not compliant as such, but it adheres to the SQL standard quite well, which makes it a good migration target. So from SQLite, you might want to go to Postgres.
Why? So why not SQL?
Well, SQL, do you mean SQL Server, the Microsoft thing? So Microsoft have opinions, and they do things very much their own way. You will find that the number of differences between SQL in Microsoft's view and SQLite is most likely bigger, much bigger, than it is with Postgres. Yeah, it's very much one Microsoft way for these things. They don't want you to leave. So yeah, for ChromaDB, there are options, right? Pinecone, just a vector database as a service. So you could do that instead. And with these two things drawn out, it's still a relatively simple view, but it's much more resilient. And you remember, Amazon, whoever, is taking care of these for you. So you don't have to worry too much about getting your 4 nines. Question that I should have asked before I jumped slides was whether there's any value in doing something about these two guys on the box. And you know what, there's a case to be made either way. So can anybody suggest, if I go back a slide, some of the problems that we might have from these two just being here like this, just deployed on the metal? Dima?
Maybe if we go to scale.
Yeah, go on.
It might be fails, for example, if some people go to the front end and ask to process some heavy processes on the back end, it might be frozen on the back end side. So then we need some more flexible architecture.
So to scale them independently? Yeah, that's definitely something you might want. But it goes both ways. So you might want that. You might also be happy with scaling them as one thing though. So if we have the back end and the back end is the slow thing and the front end is really lightweight, well, we'll just scale them as a unit. So just have more of these boxes. It's slightly inefficient, but at the scales that we're talking, probably fine as well. One thing that, actually before I go on, any other ideas for what's not great about this? Okay, so I think there's 2 things that spring to mind for me here. The first is that this box is, if you just deployed your applications onto the box, you've SSH'd in and you've pulled your Git repo or whatever, or you've SCP'd across a zip archive with your source code in it, and you've apt get installed Python, Node.js, whatever you needed in the box, a lot of manual setup, and you are responsible for keeping that box up to date and running and alive. And as you deploy new things and change things, you've got to make sure that you bring it along. You don't really want to be doing that manually. That's tedious, to say the least, and also very likely to go wrong. You will forget, somebody will forget. You want that kind of automated. Now, there's lots of solutions for doing that. But this is another layer that you want. So you could do something like use Ansible. Ansible is it's what we call an orchestrator. It uses SSH to connect to machines on your behalf and perform actions on your behalf and make sure that the state of that machine is the state that you have in your configuration file. It's one of about 1 million YAML-based DevOps tools. Every DevOps tool uses YAML, which is for worse, very much for worse. You could do that, but the boilerplate solution that Dima has excellently set up for you guys, it's running in code spaces, right, in GitHub. And to do that, you have containerized applications to run in code spaces. Do you guys know what containerization is?
That's do like Docker.
Yes, Docker. Everyone's clear on before I go on? Cool. Containers are great. Why not just put those directly on your target server. So, I mean, then you have the really nice property that what you're developing on is exactly the same as what ends up being deployed, because this is some Linux box, yeah? EC2 instance, by the way, it's just an Amazon server, basically. It could be any Linux box. It will probably be running Amazon Linux, whereas I imagine that the containers I should say the images that the containers you guys are using come from will be most likely Debian based, because they're going to be something like Python, Buster, Slim, something like that, yeah. So you've got a slight difference, and then stuff, there's little differences will cause problems, because something will work in your dev environment, and then it won't work when it gets up there, and you won't know why, and you'll debug it locally, and you'll be like, no, this works, this is great. And then, yeah, you'll find out, and you'll cry. Experience. So ideally, you want to deploy the containerized solutions up there directly. That brings with it quite a lot of faff, though, because to run containers, you want an orchestrator for your containers, something like Docker Swarm or Kubernetes. You, again, like with the database redundancy and replication, all that, you don't really want to do that yourself. You want somebody to do it for you. So what you want there is what will be known as a platform as a service. So somebody else's Kubernetes cluster that you can deploy to. Kubernetes, you guys know Kubernetes? You have Kubernetes? Okay. So I see quite a lot of vacant stairs though, so I might do a brief explainer. I mean, it's easy though. It's just something that runs containers for you. It takes care of things like making sure that the containers can talk to each other and that you can refer to them by name. You don't have to like find the IP of the container. It'll have its name resolution system in it. It will take care of talking to the outside world, but not allowing everything to necessarily talk to every container. All those kinds of networking concerns like restarting the thing when it falls over, make sure it actually just automatically restarts, taken care of. Oh, and things like deployment, right? When you deploy a new thing, ideally you want your old thing to stay up until the new thing is ready. You don't want just like they're both down at the same time and your users are going, where'd it go? Where's my bank? Something like Kubernetes will take care of that with like rolling deployments. So a good solution, like this is kind of looking at production, is Kubernetes cluster. KATES is like an acronym for Kubernetes. It's a thing that Silicon Valley people do. They stick numbers in the middle of words, and because it's easier than typing it out. And then you read it and you say KATES, because that's what that says. That says KATES. And if I say KATES, I'm sorry, I mean Kubernetes. Fargate is like a managed version of that for you on AWS, and basically all the cloud providers will have some equivalent. Again, you pay more for that than you would for running your own box and setting it up yourself, but you're paying for the convenience and all the guarantees. So that probably a pretty decent production solution. And it's not a million miles away from where you started, but you can see that there are things that would need to change and that you need to be thinking ahead for. Okay. So I couldn't resist doing this bit because of where we are. So does anyone know who that is? No. I mean, I've been a bit mean. I haven't chosen the most common picture. He gave this place its name. Oh, no, I mean 42. Sorry, I don't mean this building. Sorry?
Is it heavy?
Douglas Adams. Yeah, he wrote some books, fantastic books. Yeah, an author, books about a funny robot, including, do you guys know why this place is called 42? Why you're... There you go. The answer to life, the universe, and everything. Yes, the computer.
8 million years.
That's right. His invention. Besides the books, he also did a lot of essays and talks. And my absolute favorite is, it was called "What Have We Got to Lose?" And I'm going to veer a little bit into philosophy, but I will come straight back to tech, I promise. It's kind of like the philosophy of product development, and the idea that to improve a product is actually, like, the best way to do that is to take things away from the product, which sounds obviously counterintuitive. Isn't it better to add features to improve something? But he's taking a much higher level view. The thing that exemplifies this the most is the telephone. You think about, like, the Alexander Graham Bell telephone. The original thing was the mouthpiece and the receiver, or wires, right? That developed an awful lot. I mean, it started out with, yeah, like a dial. I think you had the mouthpiece on the thing, you had to hold it up, and you had a separate earpiece. I mean, the first thing to go was the separation between the mouthpiece and the earpiece. You ended up having one thing. Why we do that? The younger ones might not have ever seen one of those phones. Yeah.
They do this.
Yeah. Oh God. Yeah. Anyway, I digress. So you had that, but still wired, right? There's still a wire between the handset and the body of the phone, and a wire all the way down to the exchange, the switchboard, to connect you to the rest of the network. The next thing to go was, well, one of, playing fast and loose with history here, the wire between the handset and the body. You had a handset that you could walk around the house with, and you could, your buttons on the handset, you could walk up to your bedroom, make your secret calls. But that's still kind of tethered to your house. Not great. So the next thing that went was, we realized, oh, hey, we as a human race, I mean, the phone can talk directly to a radio mast. It doesn't need this thing and this cord tethering it to the exchange. So we get mobile phones, right? And you must have seen the old ones are huge. They're massive. They're bigger than my hand. They're massive buttons on them. They shrunk, and we realized as well, they don't actually need the buttons. It's actually better to have just a dynamic screen. And you end up with, like, with one of these black slabs, which looks nothing like the original phone. It's lost so much conceptually, but it's an infinitely better design. So that's a kind of hardware example of losing things. But I bear it in mind an awful lot when designing systems, because I think, okay, is there a part of this system that we could knock off and end up with a simpler, better system? Is there something that's not pulling its weight? Is there something that's adding complexity, adding challenges, and not actually strictly necessary? And that's the thing I really want to encourage you guys to think about with your solutions. So I think all of you have got multiple boxes on there. And I imagine that most of you will find that you don't need all of what you've got to deliver the solutions that you're looking for. I can't prescribe what things to take away and say, hey, you don't need that. But if you guys think about it, and I'll give you an example with my kind of dummy solution there of things that you might consider taking away and how that helps. How am I doing for time? Good. So yeah, that was the dummy solution. That's the production version. Can you guys suggest to me anything that maybe we could take away from this? Anything that we don't actually need?
You take away the user, there are no bugs.
Traditional, very good. Okay. I mean, there's a 1 in 4 chance, so.
Could you join the SQL and the ChromaDB?
Yes, yeah, you could. So you've got 2 databases, yeah? 2 stores of data. 2 annoying things to manage. you have to ask yourself, when you're fetching data, am I fetching it from here or from here? You have to say, well, I got it from here, and I also got these things from here. Can I merge them together, match them up again? Do I want to do that? A lot of faff. And you're doing it because it's different types of data, right? User data, you want to store it in tables and records. And these are vectors. That's not SQL. However, I said before that there's so many vector databases out there. Well, there's also one that you can get in Postgres. So Postgres has a very well-established extension called pgvector, which will let you do vector search in Postgres. So, hey, you don't need that. Bye-bye. You can have it here. Now, there is a trade-off to make, because when you do that, it takes a bit more to set up, but it's not massive to set up. I mean, there's a Docker image that you can run with, so that's what I would suggest. And when it comes to your cloud providers, I know for a fact that AWS RDS will let you add pgvector as an extension pretty easily, so that's fine. But yeah, so beyond wondering where your data is, there's also the advantage of I only have to learn how to use one database now. My precious mental energy has been conserved, and I can worry about improving my drawing and other things. Okay, so that's a great one to get rid of. There is one more thing that could potentially go in my damning solution. Sorry.
Local LLM.
Sorry, local
LLM.
There isn't a local LLM in it, but we're calling out to Anthropic. Oh, you're saying put a local LLM in. I mean, that's adding things. That's.
If you're using it for like Next.js, the front end and back end kind of together, right?
Yes, exactly. Cool. Yeah, right. So backend is Python, right? But what are you doing in the Python that you can only do in Python? I mean, I love Python. Much prefer it to TypeScript, to be honest. But thinking critically, if your solution is just doing RAG, okay? So your backend's main job is to generate some embeddings and for your queries, and ask ChromaDB, hey, have you got any vectors that are close to these embeddings? Yeah. Then it's not doing an awful lot. I mean, you can just ask Anthropic for embeddings and you'll get really good ones. You don't actually need it here. Now, caveat, you might be doing something interesting. If you're doing something, you need to use scikit-learn for clustering or some interesting thing like that, then yes, you have a case for Python. But if you're doing things that can actually be done just asking Anthropic, asking your OpenAI or whoever, yeah, you don't need that. And then once again, all the same rules. Do I have to ask, do I need this data from the back end? No, there's only one end. Fantastic. You might have custom models that you're running here. It's true. That would be a good reason to use Python. However, I'd also ask, what are those models doing? Because we now have the magic model provider in the sky that does an awful lot. I mean, everybody's like interested in LLMs for the text generation and creating blogs and stuff like that. Boring. What's fantastic about them, why I love them, is when I'm starting a project, I don't have to train my own model ever again for the start. Okay, I want classification at some time. I can just do a zero-shot request of an LLM, and it'll be good 60 to 80% of the time. And I can fine-tune that to get that to a nice level. I don't actually need to run my own model. Same for all the other tasks, entity extraction. That you have this super low-effort model hosted by somebody else that you can call on. That's really useful. So you might not even need to be downloading things from Hugging Face and running them. Okay, you might just be able to do zero-shot prompts, get an answer like that. And you can take this completely away. When you end up with a much simpler solution. Go on.
Can you just explain what the zero shard?
Oh, sorry. Zero shot is probably an old word now. Instead of training a model to say, like, here are some examples, and it learns like from the correct ones and predicting. You just take a model that's already got a load of latent knowledge, something that's been trained on a big web crawl and is good at text or images. It works everywhere. And you pass it a brand new task and some description of that task, and it will do it for you without the training. It just means without training, really. I think so. Zero-shot models were actually a thing before LLMs. I mean, hey, this is a bit getting into the AI history, and Daria can give a much better overview of AI history than I can. But yeah, zero-shot classification has been a thing with what we call natural language inference models before, which would say, does sentence 1 entail sentence 2? And then somebody figured out, well, if sentence 1 is like a classification question, that you can just check your answers for sentence 2, and you have a model that will be able to answer questions, classify things that you didn't have to train. And that's, wow, not training models. I mean, that's fantastic. Nobody wants to train models. It's slow. It takes ages. You get it wrong, you have to go back to the start. No. So zero shot, fantastic. And LLMs have just put it on steroids, because whereas before it was still, accuracy would still be questionable. Now it's easy to do. It's an API request. You don't even have to run the NLI model yourself. And just prompt tuning will get you an awful lot of the way to getting good results. So I think we could, at least in my dummy example, we could get away with this. And that's much, much easier. And in fact, I mean, I haven't bothered to update the green boxes, but when you have one thing like this, you don't necessarily need it to be running in Kubernetes on a cluster. I mean, if it was a Next.js solution, you could run it on Vercel. If you do that, you need to think about connecting securely to your database, but that's okay. So yeah, you've got something that's much freer. Freer is in more flexible, much easier to work with, and that headspace is conserved because you're not worrying about, hey, what about the interface between the front end and the back end? If I make a breaking change in the back end's API, what's going to happen? Do I have to deploy them at the same time and make sure that, because if I deploy the front end and it's incompatible with the back end, so then for about 5 minutes, it's not going to work. And it is this kind of stuff you don't really want to deal with if you don't have to. And the question that you should ask yourselves with respect to the projects that you're doing is, would simplifying it down to something like that impact my ability to deliver the MVP? Okay. And the question, the answer will be different for all of you, I expect. But that's the kind of thinking that I'm saying do. Think like that. Think, what have we got to lose? What problems am I going to have? And can we simplify these things and end up with a much smaller, tidier solution, simple in the words that I want to impress upon you. Okay. Summary. I'm supposed to have a summary. I mean, that thing I just said was largely the summary, right? So now would be a good time if any of you have questions.
So,
sorry, Dima had his hands up. Lightning.
Okay, so my question is, okay, if we do monolith solution, how we decide to choose the right tools to solve our problems? Why I'm asking that? Because, for example, on Python, the data science actually growing with this language. And there are a lot of tools out of the box who help us to build the pipeline with less actual knowledge of low-level technical stuff?
That's a fantastic question, because that is exactly the trade-off that you need to consider. Like, okay, if I'm exploring though, do I want to explore in TypeScript or do I want to explore in Python? And for data science things, you probably want to explore in Python. Of course, you could invert it though. You could say, did I need the front end to be in TypeScript? I mean, you're going to have some like browser stuff that will be TypeScript, yeah? But do I need a TypeScript? Let's go back. Do I need that to be a TypeScript server? Could I actually do the majority back here and have like a Python web app, like a Django or something, which is also an option. And if you've kind of just gone ahead with like, hey, I've got a front end, I've got a back end, two things, without thinking about that, you could kind of develop yourself into a corner where you have a lot of logic here, a lot of logic here, and you really, really want to get rid of one, but it's going to take you a long time because you got to, port one across to the other. So that's the kind of thing that it's good to think about up front. Is there a technology choice that you can make that will support you from the birth of the project all the way through to its adulthood? And that's
But when you create MVP, and it is going to be a part of some old infrastructure, you have to rely on the service that you have already.
Yeah. So constraints like, are you integrating with some existing thing? Yeah, that really narrows the problem space. You may only have limited choices. Of course, if at all possible, get away from the legacy thing because it will absolutely slow you down. If there's any way that you can test your idea without integrating with the legacy thing, even get like a data dump or something, work with that, you'll be able to move faster. So that's my tip in that scenario. No, you're good. Okay.
We have also one question from Lucas, which is connected from the Google Meet. I was just waiting for his question. Yeah. Lucas, if you hear me, you have a couple of seconds to let yeah, so sorry, no questions.
So much pressure.
Yeah.
How important is to keep the maintenance in mind?
Did you say maintenance?
Maintenance, yes.
Maintenance.
Yes. Yeah. So there's kind of two schools of thought. The one is that an MVP is made to throw away, and that and it is the best time to take on technical debt. Do you guys technical debt? You know that term?
Yes.
Nodding. Good. It gets you want the priority is to move fast, develop fast, and that is at odds with building a maintainable solution. However, I have seen countless MVPs that did not get thrown away, that were pushed into, I'm guilty of it, James knows, I've done it, that have been pushed into production, I've got customers using them, and live, maintenance a concern. So while I wouldn't prioritize maintenance, I would be really careful not to dig a hole to make sure that I'm, where possible, choosing things that won't hurt me too much in the long term. So, like when you're picking dependencies, pick like mainstream, well-supported stuff. Don't go for whatever was at the top of Hacker News today because you like the sound of it and it fits. Give it the same kind of critical assessment of like, okay, is anybody, supporting this package? Do I have to install it from source? That kind of thing. You want to try and bear that in mind. And yeah, just be judicious in what you're choosing, particularly around dependencies. And there's things you can do for free that will help you in the long term and won't hurt you when you're doing an MVP. So stuff like specifying your dependencies. So if you're working in Python, the Python package ecosystem is, I have no kind words for it, okay? It's terrible. The kind of common way to specify your dependencies is requirements.txt. And it's pretty common just to have a, if you're lucky enough to have a requirements.txt, it's common for it to have contents of just the names of the packages, okay? Which is, it's not gonna work for very long. You've got all sorts of problems with that approach. So version drift, right? The package is being upgraded all the time. If you try and install that on like, install that same file 6 months apart, you will get totally different things. And you can specify the dependencies, like the versions in that file, and I strongly encourage you to do that. That said, the dependencies that you've chosen have dependencies of their own, and some annoying person who builds those dependencies has probably just done a requirements.txt with names in it at some point. So there'll still be drift. So what I would recommend is picking a tool that works out like a lock file. So something like Poetry or Conda. These are easy to use. In fact, they're easier to get started with than pip and venv, because virtual envs, because they do it all in one. So they're easy to use, and then in the long term, your environment will be much more reproducible than the original environment. So that's a strong recommendation. It's basically cheap. Hey, David.
I have two questions. So since you said MVP is meant to be away, what's the duration? And second question following that.
Okay.
So if we know MVP will build is to test the idea or test what is lacking, what is needed to improve, or what's the replacement, and then does that mean if we decide that it's going to be built away, right? During this time, are we going to research it parallel? Like, okay, we're going to replace this. This is not going to work.
Yes. The first question is very hard to answer. Like, how long? It depends. I mean, you will have different drivers for when you're production solution. So one thing you might find is that choices that you've made in your MVP preclude some features that in early feedback, your users say, I really, really want that. So for example, if you've just kind of hooked into a third party, like authentication, like Auth0 or something like that, you might not have a user database in your MVP. And so doing user preferences is actually out of the question. So that maybe that when you hit that kind of crunch point, it's like, well, this technology, this application as it stands, definitely cannot support what we want in the production version, or that's an absolute kind of deadline. But that said, and this kind of comes onto the second question, your MVP will be adding features, it will be learning, knowledge will be accumulating in your code because you'll have had feedback and you'll have implemented that feedback. And I am 99.9% sure that you will not have written a nice document saying what the feedback was and why you did the thing. You've probably just done it, right? That's the normal human way. So when you do switch over, you have the risk of losing knowledge that is accumulated in code. And then you say, well, I've got a brand new shiny production version that was built from scratch. And it's better, technically better in several ways. But from the user's point of view, it may be worse in different aspects because there were things that, like daft stuff like, hey, the users actually really hate red, meaning negative, because it's like it looks bad when we show the boss the red line. Could you make it yellow or something like that? And then when you shift them over to the production thing, they're like, oh no, red lines, this is terrible. And because you didn't bother documenting that, it's a tiny thing, and whoever re-implemented it said, yellow's daft, let's just do red. Like, knowledge was lost. James and Bron know this so much. It's basically directed at you. No, we're more directed back at myself, because this is what I'm going through with an MVP at the moment. So yeah, so it's very challenging to do the switchover. I mean, and that's the reason why you may not throw the MVP away. You may say, can we just fortify it? Can we take, and or build a new house for it, take the code, put it in a new framework, that kind of thing. Which are not, like, ideally not what you want to do. Ideally, you do want to do a clean room implementation that's like throwing bits away, simplifying, okay? But in the real world, you may not have that luxury. That may not be the optimal choice. And that's about it, I think. Thank you.